Hi, just wanted to give you an update on my Stripefix board. And it's based on Stripefix from the German Forum 64DE site. And also another board. And also the original design. So it's a mix of, and I have also done several things to improve the picture, as you have seen in my earlier videos. And I'll also show you SketchUp at some point, and I found this cool plugin. So now I don't have to make these boards manually in the plugin. Yeah, so this is the board, and you can see, and also I mentioned that I have ordered this tonight, or last night. I ordered 10 of them. So yeah, I'm excited. And when you look at it like this, it looks very overwhelming, so we'll go through it. So the main thing here is that you can use this under a wick chip, or you can use it at the modulator port pins. So you can use it as a modulator replacement. It has Luma, Chroma buffering, and also composite. So actually I haven't tested that on a breadboard yet, so that will be exciting. But it's not rocket science, so I guess it will be fine. But anyway, we'll have to test everything. So yeah, so also I have an inductor here on the Chroma line, so that's a little bit different from the Stripefix board, I think. I can't remember that exactly now. So yeah, so let me show you that plugin. So here it's called eagleUp. So Eagle meets SketchUp. So link it in the description below. So that basically, when you have Eagle, like here, this is Eagle, so draw your board, and you have SketchUp, so you can draw your 3D designs like this. So whenever you have a solid or a surface, you can make a box, and making boxes handy. Anyway, so, and you have SketchUp, you can then make 3D models of your board. And the thing is, in Eagle, every device here has a package. Like if I look at this package here, you can see here in the library for these devices, you have, amongst these 74,000 series, you have 74L14, that's one particular device, and you can get that in several different packages. So this is the SMD variant. And the thing with that, this plugin, this looks at those packages and picks them out from a library. So here you can see my Eagle directory, and it has all the libraries and everything. But I also have a SketchUp models directory. So they are 3D models of packages. For example, very typical transistor SOT23. Let's open that. Let's have a look. So this is a SOT23 in 3D. And the thing is with this 3D model is that it does everything automatically. So you can also draw this yourself and put it in the directory here. I have actually done that here. This one I have drawn myself. And the thing you have to watch out for then is to make it center, so you have the center line in the middle there, and also where it touches the board, it has to be on the plane formed by the red and green axis. So I draw this. It's an inductor, so I just draw as if there was a wire going around a ferrite core. So, and you solder here, and there's a plastic, I think it's to protect it or something. I've never seen that before. Anyway, it's the miniature. So you go to installation, and here I ran into some problems, but they were easy to fix. So what you need is Eagle, of course, and then you need SketchUp. So they say currently 2014, but I have version 8 because the latest versions, I'm sorry, but they are so bloated and they require so much of my computer, so I don't think I can run it. I haven't tested it. Anyway, I don't like that. So, and then you need ImageMagick. So ImageMagick, that's a command program, and you don't have to type anything. You just need the program. It's just an exe file or a DLL. Create, edit, compose, convert bitmap images. It can read and write images in a variety of format. So when you have these 3 programs, they say you download this plugin though. But where I ran into a problem here was that they say you can install with a SketchUp extension manager. It doesn't work in that. Maybe that's something for the newer, and also it doesn't support RBZ-C, or what do you see in English? RBZ files. So eagleUp import RBZ. If you open that in a text editor, you will see that it's no more than a zip file. So let me do that now here. So if you go to that plugin, you see there's an RBZ-C, and if you view it, you will see it's just a zip file. So if you extract these zip files, you can rename the RBZ file to zip. Anyway, so you can extract those files directly into SketchUp plugin folder. So yeah, so that I did that, and it works great. So and also you run the import let me see, yeah, so in Eagle you run ULP files, so they're like plugin files. There are many ULP files in Eagle actually, so, and this is the one for our program. So yeah, enough about the installation. So what you do is so simple. You just run eagleUp export ULP, and then it will ask you what kind of quality you want. So I have set it to full. You don't really need that, but okay, it takes longer time. And what is longer time anyway? So because you're doing it only once. So, and this board, let's say I want 1.6mm thickness. You can select whatever you want there. And red solder mask, so the solder mask over the board will be red. And gold plating and white silk screen. So silk screen is the text you see here now. So you press OK. And now you're finished with Eagle. So now you go over to SketchUp. Oops. Damn. So now you do import eagleUp, and then you will have to find your file though. The thing is, I configured it that it always stores it in a folder called eagleUp export. So whenever you created this, whenever you run this here, and you are in this folder here, Eagle projects, C64, Stripefix, blah blah blah, then you will get a file in that path, but you will also get it in this folder, subfolder. So you just open that, and if you have configured it correctly, it should find all the component models, 3D models. So now it's image converting with the ImageMagick. And the thing is, for some reason in SketchUp, many of the models you have, they are at 1000:1 scale. So 1mm is 1000mm. for some weird reason. So, but this plugin, this recognizes, it's so handy. So you just press yes on all of that. It seems that this package is quite large. Do you want to resize it? Yes, thank you very much. Or if you don't, you'll get 1,000 times larger than it's supposed to be. So yeah, and there you go. And just get it down to the board. There it is. And for some reason, I made another package from. I think I made this package from this package, and there's one more leg on it than this package. So for some reason, some of these legs are gone. So I just reloaded. I don't know what happened there. So, but I have changed the package file. So, but it didn't help. So I just reload those files though. So what you do, you right click and press reload, and you can reload it. Anyway, so all of these changed now because they are the same component. Yeah, so here you go. Isn't it nice? And now you can render it in, there are different rendering programs, but anyway, I'm not in for the eye candy, although I do like the visuals here. So yeah, so what I did last night before ordering it was to put a lot of effort into making this silk screen okay. So when I did the soldering of the C64 saver, I really enjoyed that I had this silk screen here, so I didn't have to look anywhere else than on the board when I mounted it, so I didn't have any need for any reference. And these are optional, so you can yeah, you can use this pad, but then you have to solder them. So basically this is the board, and sometimes people want a modulator, so therefore you can hide this stuff here like this. Or if this is a 9-volt board, you can see down here it's 9-volt or 5-volt. If it happens to be a 9-volt board, you can have a 5-volt regulator. But if you don't need that, you can remove it. Or and the thing is, I have solder jumper here. So if you solder here, put a solder blob here, then you're bypassing it. So therefore you don't need it. Or if you don't need it, you can bypass it. So yeah, I have several things. So but before I get into that, let me just show you what I do now. Now I have this model, it's ready to go, so I save it in my project file, which is the Eagle projects, and I have a subfolder called SketchUp, and I call it PCBUp. You can call it whatever you want, and like this, and now I can use it in my model. So let's get to the Stripefix board. I have already done this, so here you can see it. So now that I have updated it, you can do a right click and reload. Yes, please. And then you load the file. Actually, it looks like I made a mistake here. I think I saved it here, as you can see. Oh no. Yeah. Let's try this again. Save this file. That's the problem with this thing over here. You don't. Once you're in SketchUp, you don't see where you are unless you press this button. So, no problem. So let's save it over that. Now it's replaced. Let's open Stripefix. So here it is. This is a model. I have turned off all of the stuff in here. So if I switch it on again, you can see this is the reason why I have this model, because I want to check that nothing interferes with the board and that it fits all of these revisions: 250, 407, 425, 466, or at the Modulator prints. Let me show you that in a short moment. And on the C64C469 board. I haven't included the earliest Commodore board, the 300,000 something, because it's I don't think this board will help that much there, and also it's too tight for it. So yeah, so where was I? Yeah, now I need to reload this board, because now I have updated this PCB model on mine. So there it is. Nothing has changed. I think it's the same as last night. So now I can see that yeah, it fits very well. There are no problems around here. And also I have some 3D models under, such that I know that it doesn't hit anything. So if I go to, let's see here, now I have to go to my SketchUp folder, and I have a Commodore. I have this one. I have downloaded actually, but I have done something more to it, because it was just a big blob of a very nice big blob of Commodore though, but maybe it's depth Q. No. Anyway, so the thing is, this was a one big model, was not grouped in any way. So what I have done is that I have grouped it. So I can now I have the keyboard alone, and I have the top. So I can lift it up. So maybe I should select the keyboard at the same time then. There we go. Follow on the blue axis. Yeah, so that's what I did though. So now I can, in theory, if this model is exact, I can see if this keyboard will be in the way. That's another problem I was going to talk about. Because if you put your Stripefix model replacement here as a board under the VIC chip, and not at the Modulator now, then you may have your keyboard in the way, because it gets too high. So this video is going a bit here and there. So this is called 3dwarehouse.sketchup.com, and if you do Commodore here, you will find a little model. I think it was this one. So it's made by Commodore Cheetah, and he uploaded it in 2013, and this is a SketchUp 8 model, so that's fine, because I have a SketchUp 8. I have some problems with newer models though, but very often they upload and include older versions. So yeah, so you can watch it in here, and there you go. So you can actually it's renders much better here than in SketchUp, so maybe I should update my SketchUp soon. Yeah, but anyway, I do like this. Now I'll hold the shift button down so I can move it. Once I release it, I am rotating. So, and when you roll the wheel, you can zoom in. So, but what I found was that wow, look at these boards, are really nice. They are not actually board, it's just a cutout there, so simplified for the model. But I think it's a great starting point. I want to ask this guy if I can continue on his model, so it will be really great, because then other people modifying Commodore 64 will find this useful if they like to use SketchUp anyway, you know. I really love it, because then you can get a feel for how much space you have at any time. So, yep, so that's SketchUp there. I have some scenes for you here. So this is the Modulator board, or actually now I called it C64 video buffer with Stripefix. I'm sorry, I don't have a good name for it. So. But now it's such that it can be put onto the Commodore 64 at the big ship area. So yeah. And the next scene, yeah, I just show you the 3mm pot meter here. And this is when it's used at 250-407 board. And the thing here was that, as you can see, let me just remove the PCB for a moment. So what you do, you just hide these guys here. So what I did was that I made a box everywhere. I thought everywhere where there was components, such that I can figure out if the board will fit though, and if there's some soldering stuff under the board, on my board anyway, so such that they don't touch anything under there. So, and as you can see here, the thing is that this capacitor that was here, it usually you just bend them away, like here. This one here is already bent down. You can see in this picture. But the thing is, with this one can't be bent down, because if you bend it this way, it will just touch the pins here. If you bend it this way, it will touch the wall that is around here. So what I did make a cutout here though. So that's a very, very good thing to have these 3D models. It was a pain in the behind. So yeah, so let's get to the next scene though. So this is the 250-425 board, and it's yeah, it's a little bit different. That's when they throw away all of this PLL stuff that I had before. Now they have a simpler timing circuit based on one chip. So this is 466, and as you can see, if I step between these two, you can see they are very similar. This is the 25 and this is the 26. Oh, 66. 466. And then you have the 664C, which is upright, as you can see. So, and there's no problem here also. So this is a bit close, but there's still room, so no problems. And then, oh no, maybe there's a problem with this. I forgot about that. There is a capacitor here, but I'm hoping that it can be bent in between here. Oh no. Let's hope there's room there. It looks like it's okay. So I hope someone can test that for me, because I don't have a 664C. I have the other Christmas tree version that I call it, the 466. Yeah, so this was the last of the larger board, and it was included in the Commodores that look like the 64C, but it's not really what you expect, because you expect another chipset. So you can choose if you want to have your circuit here. If you want, let's say you have a modulator already, you don't want all this circuitry here, then all of this will be blank. And what you do is that if you see here, you will have two pads, and these two pads are connected to this socket. And the reason why I did that is, if you look at behind here, is that you can, if you want to send the chroma signal directly out on the pin to the motherboard, because this pin goes down on the motherboard, you can do that, but you can also drop it such that it will never go that way. It will only get out on these pins to the left here, such that you can route them by yourself, so you don't have to route them over the noisy motherboard. So that's a choice you have, actually. So But let's say, as I started saying, to get back to the point, if you don't solder all of these components, you just want a Stripefix, then you must solder this jumper here now, so such that you get these two video pins down onto the motherboard and over to your modulator that you don't want to change. So yeah, and also you can drop the Stripefix if you want, if you just want the modulator. So yeah. So here comes the last part, and now you can see the ship. There's no ship in this at all. There's not supposed to be a ship there. Now the board is mounted at the modulator pins. So now you can have a modulator yourself, or a video buffering anyway. It's not a modulator. And yeah, so, and you can have Stripefix if you want. You can drop this part if you want, if you just want this part. So yeah. And also, if the board is 9 volts, then you can have regulator. Let's say, but if you have a newer model which is 5 volt, then you can just drop these parts here. Then if you do that, you will also need to see this solder jumper. You can bypass it. Yeah. So let me just put them back here. As you can see here, this is the main source of noise on this. Those are the actual stripes on you see on your screen. They are caused by ASC signal, or at least they are correlated in some way. Not know exactly how, but what it does is same as the other Stripefix board. It comes in on this device, and then maybe it's easier to see it here. You can see it here. You see the ASCs, the blue one going over here, and then in on this pin. And then you have this inverter, so it comes out inverted and into this via resistor into a pot. So you can adjust the ASC portion here, how much you want to counteract. So, and then on the output of that pot is now capacitively coupled here back to the Luma. So, and you can see it's a bit messy though. It comes in here, this solder jumper. Let me just turn off the red one. No, it doesn't really have. Anyway, you can see it down here, and you can see a solder jumper. So let's it's maybe easier just to look at the schematic actually. So let's do that. So yeah, here you can see it. This AC signal, resistor, then a potmeter, then a capacitively coupled into this solder jumper, and then you have the option to connect that to the Luma in or the Luma out. So you may ask me, why didn't you just connect it to either of them? Yeah, the thing is that the reason for in the first place to connect it to the Luma out was because I know this is a low impedance point, and this here is a high impedance point, and on most of the other Stripefix board I've seen, or the jailbar fix boards, they connect onto the Luma in. That means the high impedance. So, and if you do that, then you are adding 47 picofarad, because this part here is very close to 0, or somewhere within 50 and 0 ohms, or here for that matter. So you get 47 picofarad, and it doesn't sound much, but at 1 megahertz, that's actually, and at this impedance here, it's actually quite something. So you get softer image, and many people have some just say it looks nicer though, so I'm not going to argue anyway, but you have the option to connect it to the Luma out, because then the signal here, which is high impedance, it's matched with this high impedance input, and then it's converted into a lower impedance signal, and then this capacitive coupling here doesn't load it that much, so it doesn't make the screen any dimmer or softer. So yeah, that's the reason. So, but why, as I said, why didn't I just connect it here then? Well, there may be some reason you want composite, for example. Well, if I connect it here, then I don't get Stripefix on the composite, so therefore I have to have an option to source those Stripefix in here, such that I get it to my composite. So yeah, so that's it. So there it is. You can see then Stripefix comes in here. You can then solder this two part and get it on the Luma in. So I have in the last minute before ordering the board, I wrote this on here. So I thought it was a nice touch. So you can select these two down. So yeah, and you have other bypasses here. You have this I have talked about. So you can send it down to the main board if you want. And yeah, this is very important for this part we are talking about here. Yes. Yeah, it depends on which motherboard you have. If you have a late one, I think they or actually know this. You can see here on these two pins, you have audio chroma or you have chroma audio. So these two pins are interchanged for some stupid reason. So so therefore you have a option under here to select. Yeah, there you can see it. So you can select which one you have. So I haven't written exactly what it is, but I think it's if you have 64C model, then if you look at this side, yeah, you can see then you have chroma on this, on pin 4. But if you have an older Commodore, then you have chroma on this pin. So yeah, I had to make up for that mistake they did at Commodore there. Yeah, and there's another, this one is not that exciting. You have to put a solder probe there if you're not going to use the third pot. So you have the option to use the third pot, and that basically is another, if you want to experiment, I have given the option to can put a signal here and it will be inverted, and then you can add a pot here to feed back to the Luma. So I can hide this also because it's not in use, as you can see. Yep. So that's basically it. I think I have covered most of it. So yeah, thank you for watching, and when I get bored, of course I will show you more, and